School of Management Studies IGNOU presents an audiobook on the course MMPC-005 Quantitative Analysis for Managerial Applications for MBA program. Block 1 Data Collection and Analysis. Unit 3 Measures of Central Tendency.
After completing this unit, you should be able to understand the concept and significance of measures of central tendency. You will be able to compute various measures of central tendency such as arithmetic mean, weighted arithmetic mean, median, mode, geometric mean, and harmonic mean. You will be able to compute several quantiles such as quartiles, deciles, and percentiles, and also learn the relationship among various averages. Introduction. With this unit, we begin our formal discussion of the statistical methods for summarizing and describing numerical methods for summarizing and describing numerical data. The objective here is to find one representative value which can be used to locate and summarize the entire set of varying values. This one value can be used to make many decisions concerning the entire set. We can define measures of central tendency or location to find some central value around which the data tend to cluster. Significance of measures of central tendency. Measures of central tendency, that is, condensing the mass of data in one single value, enable us to get an idea of the entire data. For example, it is impossible to remember the individual incomes of millions of earning people of India. But if the average income is obtained, we get one single value that represents the entire population. Measures of central tendency also enable us to compare two or more sets of data to facilitate comparison. For example, the average sales figure of April may be compared with the sales figure of previous months. Properties of a good measure of central tendency. A good measure of central tendency should possess, as far as possible, certain properties, which are: number 1, it should be easy to understand. Number 2, it should be simple to compute. Number 3, it should be based on all observations. Number 4, it should be uniquely defined. Number 5, it should be capable of further algebraic treatment. And number 6, it should not be unduly affected by extreme values. Some of the important measures of central tendency which are commonly used in business and industry are: number 1, arithmetic mean. Number 2, weighted arithmetic mean. Number 3, median. Number 4, quantiles. Number 5, mode. Number 6, geometric mean. And number 7, harmonic mean. Arithmetic mean. The arithmetic mean or average is the most commonly used and readily understood measure of central tendency. In statistics, the term average refers to any of the measures of central tendency. The arithmetic mean is defined as being equal to the sum of the numerical values of each and every observation divided by the total number of observations. Symbolically, it can be represented as arithmetic mean equals to sigma x over n. Here, sigma x indicates the sum of the values of all the observations and n is the total number of observations. When the observations are classified into a frequency distribution, the midpoint of the class interval would be treated as the representative average value of that class. Therefore, for group data, the arithmetic mean is defined as arithmetic mean equals to sigma fx over n, where x is the midpoint of various classes, f is the frequency for corresponding class, and n is the total frequency, that is, n equals to sigma f. To simplify calculations, there is another formula for arithmetic mean, which is arithmetic mean equals to a plus sigma fd over n into I, where a is an arbitrary point, d equals to x minus a over I, and I is the size of the equal class interval. Remark: a justification of this formula is when d equals to x minus a over I, then x equals to a plus I d multiplying throughout by f, taking summation on both sides and dividing by n, we get arithmetic mean equals to a plus sigma fd over n into I. This formula makes the computations very simple and takes less time. It may be observed that this formula is faster for calculation than the previous one, and the value of arithmetic mean remains the same. Mathematical properties of arithmetic mean. Because the arithmetic is defined operationally, it has several useful mathematical properties. Some of these are: number 1. The sum of the deviations of the observations from the arithmetic mean is always 0. Symbolically, it is sigma in brackets x minus mean equals to 0. It is because of this property that the mean is characterized as a point of balance, that is, the sum of the positive deviations from mean is equal to the sum of the negative deviations from mean. Number 2. The sum of the square deviations of the observations from the mean is minimum, that is, the total of the squares of the deviations from any other value than the mean value will be greater than the total sum of squares of the deviations from mean. Symbolically, it is expressed as sigma in brackets x minus mean whole square is a minimum. Number 3. The arithmetic means of several sets of data may be combined into a single arithmetic mean for the combined sets of data. For two sets of data, the combined arithmetic mean may be defined as arithmetic mean 1, 2 equals to n1x1 plus n2x2 over n1 plus n2, where mean 1, 2 is combined mean of two sets of data. Mean 1, 2 equals to arithmetic mean of the first set of data. Mean 1, 2 equals to arithmetic mean of the second set of data. N1 stands for number of observations in the first set of data. N2 is number of observations in the second set of data. If we have to combine 3 or more than 3 sets of data, then the same formula can be generalized as mean 1, 2, 3 equals to n1 mean 1 plus n2 mean 2 plus n3 mean 3, and so on, divided by n1 plus n2 plus n3 plus so on. The arithmetic mean has the great advantages of being easily computed and readily understood. It is due to the fact that it possesses almost all the properties of a good measure of central tendency. No other measure of central tendency possesses so many properties. However, the arithmetic mean has some disadvantages. The major disadvantage is that its value may be distorted by the presence of extreme values in a given set of data. A minor disadvantage is when it is used for open-end distribution, since it is difficult to assign a midpoint value to the open-end class. Weighted arithmetic mean. The arithmetic mean, as discussed earlier, gives equal importance or weight to each observation. In some cases, all observations do not have the same importance. When this is so, we compute weighted arithmetic mean. The weighted arithmetic mean can be defined as weighted arithmetic mean equals to sigma wx over sigma w, where mean w represents the weighted arithmetic mean, w are the weights assigned to the variable x. You are familiar with the use of weighted averages to combine several grades that are not equally important. For example, assume that the grades consist of one final examination and two midterm assignments. If each of the three grades are given a different weight, then the procedure is to multiply each grade, that is x, by its appropriate weight, that is w. If the final examination is 50% of the grade and each midterm assignment is 25%, then the weighted arithmetic mean will be given as weighted arithmetic mean equals to sigma wx over sigma w, which is again equal to w1x1 plus w2x2 plus w3x3 over w1 plus w2 plus w3. The concept of weighted arithmetic mean is important because the computation is the same as used for averaging ratios and determining the mean of group data. Weighted mean is especially useful in problems relating to the construction of index numbers. Median. A second measure of central tendency is the median. Median is that value which divides the distribution into two equal parts. 50% of the observations in the distribution are above the value of median and other 50% of the observations are below this value of median. The median is the value of the middle observation when the series is arranged in order of size or magnitude. If the number of observations is odd, then the median is equal to one of the original observations. If the number of observations is even, then the median is the arithmetic mean of the two middle observations. For example, if the income of 7 persons in rupees is 1100, 1200, 1350, 1500, 1550, 1600, 1800, then the median income would be rupees 1500. Suppose one more person joins and his income is rupees 1850. Then the median income of 8 persons would be 1500 plus 1550 divided by 2, which is equal to 1525. Since the number of observations is even, the median is the arithmetic mean of the 4th person and the 5th person. For group data, the formula that can be used to locate the value of median is median equals to L plus n by 2 minus PCF over F into I, where L is the lower limit of the median class, PCF is the preceding cumulative frequency to the median class, F is the frequency of the median class, and I is the size of the median class. Mathematical property of median. The important mathematical property of the median is that the sum of the absolute deviations about the median is a minimum. In symbols, sigma x minus median is minimum. Although the median is not as popular as the arithmetic mean, it does have the advantage of being both easy to determine and easy to explain. As illustrated earlier, the median is affected by the number of observations rather than the values of the observations. Hence, it will be less distorted as a representative value than the arithmetic mean. An additional advantage of the median is that it may be computed for an open-end distribution. The major disadvantage of median is that further mathematical treatments cannot be done. However, since median is a positional average, its value is not determined by each and every observation. Quantiles. Quantiles are the related positional measures of central tendency. These are useful and frequently employed measures of non-central location. The most familiar quantiles are the quartiles, deciles, and percentiles. Quartiles. Quartiles are those values which divide the total data into 4 equal parts. Since 3 points divide the distribution into 4 equal parts, we shall have 3 quartiles. Let us call them Q1, Q2 and Q3. The first quartile, Q1, is the value such that 25% of the observations are smaller and 75% of the observations are larger. The second quartile, Q2, is the median, that is 50% of the observations are smaller and 50% are larger. The third quartile, Q3, is the value such that 75% of the observations are smaller and 25% of the observations are larger. For group data, the formula used for quartiles is Qj equals to L plus Jn by 4 minus PCF divided by F into I, for j equals to 1, 2, 3. L is the lower limit of the quartile class, PCF is the preceding cumulative frequency to the quartile class, F is the frequency of the quartile class, and I is the size of the quartile class. Deciles. Deciles are those values which divide the total data into 10 equal parts. Since 9 points divide the distribution into 10 equal parts, we shall have 9 deciles denoted by D1, D2 till D9. For group data, the formula used for deciles is dk equals to L plus kn by 10 minus PCF divided by F into I, where k equals to 1, 2 till 9 and the symbols have usual meaning and interpretation. Percentiles. Percentiles are those values which divide the total data into 100 equal parts. Since 99 points divide the distribution into 100 equal parts, we shall have 99 percentiles denoted by P1, P2, P3 till P99. For group data, the formula used for percentiles is PL equals to L plus Ln by 100 minus PCF divided by F into I, for L equals to 1, 2, 3 till 99. Locating the quantiles graphically. To locate the median graphically, draw less than cumulative frequency curve, that is less than ogive. Take the variable on the x-axis and frequency on the y-axis. Determine the median value by locating n by second observation. Determine the median value by locating n by 2th observation on the y-axis. Draw a horizontal line from this on the cumulative frequency curve, and from where it meets a curve, draw a perpendicular on the x-axis. The point where it meets the x-axis is the value of median. Similarly, we can locate graphically the other quantiles such as quartiles, deciles, and percentiles. To determine different quantiles graphically, horizontal lines are drawn from the cumulative relative frequency values. For example, if we want to determine the value of median or Q2, a horizontal line can be drawn from the cumulative frequency value of 0.50 to the less than curve and then extending the vertical line to the horizontal axis. In a similar way, other values can also be determined. It may be noted that these graphical values of quantiles are the same as obtained by the formulas. Mode. The mode is the typical or commonly observed value in a set of data. It is defined as the value which occurs most often or with the greatest frequency. The dictionary meaning of the term mode is most usual. For example, in the series of numbers 3, 4, 5, 5, 6, 7, 8, 8, 8, 9, the mode is 8 because it occurs the maximum number of times. The calculations are different for the group data, where the model class is defined as the class with maximum frequency. Hence, the formula used for calculating the mode is mode equals to L plus D1 over D1 plus D2 into I, where L is the lower limit of the model class, D1 is the difference between the frequency of the model class and the frequency of the preceding class, D2 is the difference between the frequency of the model class and the frequency of the succeeding class, and I is the size of the model class. Locating the mode graphically. In a group data, the value of mode can also be determined graphically. In graphical method, the first step is to construct histogram for the given data. The next step is to draw two straight lines diagonally on the inside of the model class bars, starting from each upper corner of the bar to the upper corner of the adjacent bar. The last step is to draw a perpendicular line from the intersection of the two diagonal lines to the x-axis, which gives us the model value. It may be noted that the value of mode would be approximately the same if we use the algebraic method. The chief advantage of the mode is that it is by definition the most representative value of the distribution. For example, when we talk of model size of shoe or garment, we have this average in mind. Like median, the value of mode is not affected by extreme values and its value can be determined in open-end distributions. The main disadvantage of the mode is its indeterminate value. That is, we cannot calculate its value precisely in a group data but merely estimate it. When a given set of data have two or more than two values as maximum frequency, it is a case of bimodal or multimodal distribution and the value of mode is not unique. The mode has no useful mathematical properties. Hence, in actual practice, the mode is more important as a conceptual idea than as a working average. Relationship among mean, median, and mode. A distribution in which mean, median, and mode coincide is known as a symmetrical or bell-shaped distribution. If a distribution is skewed, that is not symmetrical, then mean, median, and mode are not equal. In a moderately skewed distribution, a very interesting relationship exists among mean, median, and mode. In such type of distributions, it can be proved that the distance between mean and median is approximately 1/3 of the distance between the mean and mode. Hence, the relationship can be expressed as mean minus median equals to 1/3 of mean minus mode, or mode equals to 3 median minus 2 mean. Similarly, we can express the approximate relationship for median in terms of mean and mode. Also, this can be expressed for mean in terms of median and mode. Thus, if we know any of the two values of the averages, the third value of the average can be determined from this approximate relationship. Geometric mean. The geometric mean, like the arithmetic mean, is a calculated average. The geometric mean or GM of a series of numbers x1, x2 till xn is defined as GM equals to nth root of x1, x2, x3 till xn, or the nth root of the product of n observations. When the number of observations is 3 or more, the task of computation becomes quite tedious. Therefore, a transformation into logarithms is useful to simplify calculations. If we take logarithms of both sides, then the formula for GM becomes log GM equals to 1 by n into log x1 plus log x2 plus log x3 plus till plus log xn, and therefore GM equals to anti-log of sigma log x over n. For the group data, the geometric mean is calculated with the formula GM equals to anti-log of sigma f into log x over n, where the notation has the usual meaning. Geometric mean is especially useful in the construction of index numbers. It is an average more suitable when large weights have to be given to small values of observations and small weights to do large values of observations. This average is also useful in measuring the growth of population. The geometric mean is very useful in averaging ratios and percentages. It also helps in determining the rates of increase and decrease. It is also capable of further algebraic treatment so that a combined geometric mean can easily be computed. However, compared to arithmetic mean, the geometric mean is more difficult to compute and interpret. Further, geometric mean cannot be computed if any observation has either a value 0 or negative. Harmonic mean. The harmonic mean is a measure of central tendency for data expressed as rates such as kilometers per hour, tons per day, kilometers per liter, etc. The harmonic mean is defined as the reciprocal of the arithmetic mean of the reciprocal of the individual observations. If x1, x2 till xn are n observations, then harmonic mean can be represented by the formula hm equals to n over 1 by x1 plus 1 by x2 plus till 1 by xn, and this is equals to n over sigma in brackets 1 by x. For group data, the formula becomes hm equals to n over sigma f by x. The harmonic mean is useful for computing the average rate of increase of profits or average speed at which a journey has been performed or the average price at which an article has been sold. Otherwise, its field of application is really restricted. The harmonic mean, like arithmetic mean and geometric mean, is computed from each and every observation. It is especially useful for averaging ratios. However, harmonic mean cannot be computed when one or more observations have zero value or when there are both positive or negative observations. In dealing with business problems, harmonic mean is rarely used. Now let's summarize the unit. Measures of central tendency give one of the very important characteristics of data. Any one of the various measures of central tendency may be chosen as the most representative or typical measure. The arithmetic mean is widely used and understood as a measure of central tendency. The concepts of weighted arithmetic mean, geometric mean, and harmonic mean are useful for specified type of applications. The median is generally a more representative measure for open-end distribution and highly skewed distribution. The mode should be used when the most demanded or customary value is needed.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code MMPC-005, Quantitative Analysis for Managerial Applications. Course Coordinator, Professor Anurag Saxena, School of Management Studies IGNOU. Voiceover by Harpreet Kaur. Edited by Ashok Sharma. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.